Well, again, we are continuing with the Newton's laws of motion, and our topic of discussion is friction and frictional forces. Just in brief, I will explain the friction and frictional forces, and then we will come to the main context. When we use the term friction, suppose that we consider a body moving over a surface. We find that if we apply some force to that body and the body begins to move, then in the opposite direction, some force is acting on the body which reduces its motion, and that is what called friction. So friction is a force opposite to the applied force, number one. And number two is, that is, for example, we consider a rubber ball or any other ball like a cricket ball. When it is thrown on the ground, we find that after some time it stops. This is due to that when the ball is moving on the ground, there will be force of friction exerted by ground on the ball in the opposite direction. So ball comes to the state of rest. Now, other things which are important about the friction, that is, we have to go through it, how exactly we define the coefficient of friction, the force of friction, the sliding friction, the limiting friction, the angle of repose. All these facts we have to read in the concept of friction. The other important thing regarding friction is that friction is very helpful in many cases, but it is also a disadvantage because whenever machine parts operate, the various parts begin to move, and in the various parts there will be frictional forces acting, that is, surfaces rub each other, and we find there is some loss in energy. Sometimes the loss is so great that heat is very large and the part begins to burn. So these are the main things which we are going to discuss in the friction. Then how friction operates on the inclined plane, how friction operates on the ground. These are our context of discussion. Now, first thing is about the friction and the frictional forces. We can put it like this, that is, if we slide or try to slide a body over a surface, the motion is resisted by the bonding between the body and surface. This resistance is represented by a single force, and this is called friction. So friction is nothing, it is basically a force which is producing hindrance in the motion of another body on the surface. Now next thing, the force of friction is always parallel to the surface and opposite to the direction of intended motion. So if the body is moving from left to right, the frictional force will act from right to left. We find that to start the motion or to stop the motion, friction is helpful as well as disadvantage. Force of friction is practically independent of the area. So whatsoever the area of an object or the surface, the friction is not depending upon that area in contact, surface on contact, and relative velocity between them. But friction depends on the nature of material of the surface in contact and their roughness and smoothness. So we will remember now that area is not important, area of the surface. However, it depends on the nature of material of the surface in contact and their roughness and smoothness. So if the surface is more polished, friction will be less, and if it is not polished, the friction will be more. Normally, with the increase in smoothness, the friction decreases and body can move easily. But if the surface area are made too smooth by polishing and cleaning, the bonding force of adhesion will increase, and so the friction will increase. Friction is a non-conservative force. So what exactly we mean by the non-conservative force? That is, work done against friction is path independent. So in which path the body is moving, that is not a criteria. So we say friction is a non-conservative force. The reason is that work done against friction is path dependent. In its presence, mechanical energy is not conserved. Thus, friction reduces efficiency of machine. So here we find that friction is basically a disadvantage. It reduces the efficiency of machine. So when most of the machines operate, we find that their efficiency is not set 10%, rather the efficiency drops. That is because mechanical energy is not conserved. In general, there is a misconception that friction always opposes the motion. No doubt, friction opposes the motion of moving body, but in many cases, it is also the cause of motion. So, in this concept, I have explained you that friction helps in the motion and friction obstructs the motion. In a moving, a person pushes the ground backward, that is the action, and rough surface of the ground reacts and exerts a forward force due to friction. So when we move on the ground, we find that our one foot pushes the ground backward and other foot overcomes the friction and we start moving. So we can put it like this, that a person pushes the ground backwards, that is action, and the rough surface of the ground reacts and exerts a forward push or forward force due to friction, and this causes the motion. If there had been no friction, there will be slipping and no motion. So friction is a must. If there is no motion, there is no friction, there are chances, or if the surface is very frictionless, more frictionless, there are more chances of slipping. Now, in order to effect the friction, we use certain lubricants. So, we can put it like this, that if lubricants are used, then force of friction generally reduces. So, if we don't use the lubricants, the various parts of the machine will have more friction, more heat will be developed. So, we can put it again like this. If the lubricants are used, then force of friction generally reduces. In some cases, friction acts as a supporting force, and in some cases, it acts like a opposing force. Now, there are certain examples for supporting and examples in opposing. So, in the figure, in the diagram, the motion of a person is shown on the ground as it is given by the left arrow, the pushing backward on the ground, and ground pushes the person forward. This is what indicated in this figure. So in the support, we have the following context. The frictional forces are essential in many walks of life. For example, walking process can only take place because there is friction between the shoes and the ground. In the process of walking, in order to step forward, you must press your feet backward on the ground. A friction force tends to oppose this movement of foot. The ground pushes you forward, which allows you to walk when there is no friction, as on ice or polished granite or oily surface. The walking is difficult. So it is quite easy to walk on a friction full surface. If there is friction, we can move very easily. But if the surface is highly polished or there is an oily surface, then we find that there are more chances of slipping. Now, opposing, there is certain example for that. When block slides over the surface, the force of friction works as an opposing force in the opposite direction. This I have explained you earlier. That is, we have taken the surface of table, and on the table surface we have kept a wooden block. If the wooden block will move in one direction, the force of friction will act in the opposite direction. The same thing can be explained that block slides over a surface. The force of friction work as an opposing force in the opposite direction of motion. Now, there are certain things, that is friction, that is we are supporting as well as opposing. Both the cases are simultaneously taken. So in the figure it is shown forces of friction when pedaling. So a person is cycling and F1 and F2 are indicated. The front wheel faces the opposing force, whereas the rear wheel, that is friction, helps in moving it. So both supporting and opposing, we can put it like this. When cyclist pedals the friction force on the rear wheel acts as supporting. So this I have just now explained you that F1 is a supporting force and on the front wheel as it is an opposing force. So F2, that is the force of the front wheel, will be opposing, and F1 the force of the rear wheel, that will be helping. So now in the animation or in this motion we can understand that the cyclist is moving, so the front wheel will be opposing the motion and the rear wheel is helping the back wheel to move. So this fact is indicated during the cycling. Now non-paddling, in the left side figure, when cyclist does not pedal, the friction force on the rear wheel and the front wheel act as an opposing force. So it means that during non-paddling, like for example, we are paddling and the bicycle is moving forward and then we stop paddling, that is, it becomes non-paddling after the motion. In that case, we find the friction force on the rear wheel and the front wheel act as an opposing force. Now, there are various types of frictions. Like in this case, we have to go through the rolling friction, the limiting friction, the dynamic friction, the static friction. There is various types of frictions we have to go through. So first of all, we have to understand the static friction, that is friction at rest. So if a body is placed on the surface and if it is not moving, it means frictional force is quite high and the body is not moving. So we can depict it like this. The frictional force between the two surfaces before the relative motion actually starts is called static frictional force or the static friction. Static means basically at rest. So when the body is rest, then we will say the friction will be static. Then we come across the laws of static friction, that how the static friction is governed. Now, the first point is in the static friction, that is, the direction of force of friction is always in a direction opposite to which the body tends to move. So, this I have repeated now 2 to 3 times. You can understand like this, that if the body is moving in one direction, then surface is opposing the motion. So direction of force of friction is always in direction opposite to which the body tends to move. The second point for the laws of static friction will be the force of friction is self-adjusting. Now what exactly we mean by the self-adjusting force and how the increasing force or the applied force will work. The force of friction is self-adjusting force and increases with the applied force. As the applied force is increasing, the force of friction also increasing, so as to equal and opposite it until the motion is just about to start. So just before starting, we say that it is a self-adjusting force. Now the third concept, when one body just tends to move, the force of friction between the surface and contact is maximum. The force of friction is called the limiting friction. Once more, I will repeat that when the body is not moving, at that time, static friction is maximum or the force of friction is maximum. So, when body just tends to move, at that instant of time, the force of friction or the surface and contact will be maximum. The force of friction in this case will be known as the limiting friction. The fourth point is the limiting friction depends on the nature of surface, not the area of surface. So nature, whether more polished or it is unpolished. So limiting friction depends on the nature of surface in contact but is independent of the area of surface in contact. Now the fifth point is the limiting friction between the surfaces of the two bodies is directly proportional to the normal reaction. To understand this fact, we just take a surface and on that surface we place a cubical body or a body in the form of a cuboid, and N will be the normal reaction to the surface. So when the block is placed on the surface, the downward force is the weight and surface exerts a reaction that is called normal reaction. And the friction between the two surfaces, that is the block, and the surface on which the body is kept, that is called the force of limiting friction. So what we find is that as the force of limiting friction or as the normal reaction will increase, the force of limiting friction will also increase. That's why we have written here that is FL is proportional to N. Now, once more, I will explain the concept. The limiting friction between the surface of the two bodies is directly proportional to the normal reaction. If normal reaction is N and the limiting friction is F, then FL is proportional to N.